We are live. Hi guys, we're just going to wait a few minutes to make sure that everyone's got time to kind of get into the Zoom call. But hi, really nice to see you. We're back with TRT for season 2.
That was really weird, it coming from you there, Daisy, not coming from Mark or Dale.
I
Well, we are
know.
live.
I know. I haven't even introed myself, but I am not Mark or Dale. I am Daisy, and I will be hosting today's session. And we've also got the lovely Darren and Phil on the call as well.
Hello.
Yeah, excited for this one. Java's my old stomping ground.
I was going to say, if anyone at HackerJob is going to be able to do Java, it's going to be you. So pressure is on.
Well, that's the thing. The pressure's on to get it right, and we've gone quite in depth in this one. So no, I think I'm interested to see how it goes. I'm happy to be challenged on anything. Like, I don't think any of us in the recruitment world know absolutely everything about tech. I knew quite a bit of it before. I've had to do a bit of extra research for other bits, which is good. Like, always, one of the best things I think about doing TRT is it's definitely increased my understanding as we've been doing it. But yeah, as always, definitely have to be challenged if people think otherwise, or you know, of different opinions on kind of what's important in the market and what sort of tools they're seeing. It's always good to have a discussion around those. So please do jump on the chat.
I think you set the bar very high for the following few weeks, based on the content I've seen in the last half an hour or so. So I look forward to doing 3 of these myself, where I'm going to have to do a lot of research by the looks of this.
You're fuming, aren't you, Darren? You're fuming. Phil's done such a good job.
Hoping it was awful.
Yeah, exactly. Yeah, I was hoping that you would do it like 4 out of 10, so that I only need to do 5 out of 10 in order to improve on it. But we really haven't here.
What time are we on?
We're at 12:01, so I think we should give it a couple more.
Give it a couple of minutes, maybe. Yeah. Nice.
So what have you guys been watching this week? I know it's only Tuesday, but what have you been enjoying?
I haven't watched any TV. Football's back, so I've been watching a lot of football.
How is it with the sound of the crowds versus without? Which do you prefer?
Well, I'm an Arsenal fan, so we don't really get a lot of crowd noise anyway, so it's just like normal.
Okay, all right. And do you watch football, Phil?
Yeah, no, I prefer it without. I think it's good. I had it on. I had the crowd noise on the first couple I watched, but then no, since then I've taken it off. I think it's good to be able to hear them shouting. I could hear Matt Ritchie shouting his head off during the Newcastle game, which is good. So yeah, I think I'll be keeping the sound off from now on. Dig into the tactics a bit more.
People are probably bored of us saying this, but if you want to ask questions or have a conversation, if you change your the 2 in the chat to all panelists and attendees, then everyone will be able to see what you're saying. Yeah.
But no, in terms of like series and stuff, I started watching that Snowpiercer on Netflix. It's pretty good. It's nice. It's like a dark kind of future world sort of thing where basically the whole world's frozen and everyone lives on a train. It sounds a bit weird, but it's all like class segregated and stuff. Like the front's very posh and then the back's not so nice. But yeah, no, it's good. I'd recommend it.
There's a film with Chris Evans in that is Snowpiercer as well. It's very, very good. So I recommend that.
The film's good. But it's just that, but obviously extrapolated over like a full series. I'd recommend it. It's good.
Nice.
Cool. Should we
get started? Yeah.
Yeah, sure. Okay, so hi guys, welcome for TRT Season 2. If you're new here, this is obviously our tech recruitment training program. My name's Daisy, I'm HackerJob's Content Strategy Manager, and you've also got Darren and Phil on the line with me today. So housekeeping. So first of all, our Slack group is now live. If you want to be added to it, please email hello@hackerjob.co and we'll make sure that you're added to it. As Darren and Phil also previously said, when you're asking questions in the chat, please make sure to select all participants. It just means that everyone gets to see your questions, so everyone kind of see what's going on. You'll also be invited to a new Zoom webinar each week, and make sure to email hello@hackerjob.co if you have any issues. And also please make sure to tell your friends. So we're on YouTube as a series. You can find us on Twitter at hackerjob.co, LinkedIn via HackerJob, and you can always use the hashtags TRT and Tech Recruitment Training. Our course plan. So over the next 6 weeks, we're going to be doing these kind of lunch and learn style sessions. Today, we're going to be focusing on modern Java, but we're also going to take you through full stack Node.js, front end React, AWS DevOps engineers, automation engineers, and AI engineers. So yeah, very exciting. So for today's agenda, we're going to be talking through a Java recap. We're going to be deconstructing the tech and the skills, as well as the kind of experience and salary required for a Java developer, and also looking at the interview process. So Phil, do you want to take us through a Java recap?
Lovely, yes. So you'll probably be familiar with this slide if you've looked back at the software engineering presentation we did. I think it was day 3 of series 1. So it's just a quick recap of kind of Java. We're going to be delving into all of this in a lot more depth. So maybe if some of this didn't make sense the first time as to why, you know, microservices, DevOps, data knowledge would be kind of additional demands for a Java developer, we'll try and shed some light on that, as well as kind of the Java approach to testing, a little bit more of a deep dive into Spring, particularly Spring Boot. And then I'll talk you a little bit through the versions as well. And we'll touch on some of the red flags. But I think in terms of the red flags to go over now, obviously Java Enterprise Edition, so Java J2EE, Hibernate, Swing, and Struts. Hibernate is a little bit more modern than the others, and it's only fairly recently we started to see that die out in the market. To be honest, when I started working the Java market about 4 years ago, Hibernate and Spring were both pretty much as in demand at that time. But I think over the last sort of 2-3 years, we've really seen a move towards the Spring framework, away from these older ones. As always, Android SDK Android development can be a bit of a red flag for Java. Again, we did I think our final episode of series 1, we touched on mobile development. So if you want some more insight into kind of the relationship Java has with Android, then by all means go back and listen to that. And then when we're looking at responsibilities, so like fixes, monitoring tickets, support, I think that's pretty universal across development. If you've got someone that is only working in a support capacity and they're doing kind of minor bug fixes, they might not be the right person if you're needing someone to come in and work on like a fresh greenfield project. And then, yeah, as always, the names Java and JavaScript are not related. So yeah, and that's a pretty rookie mistake. I'm guessing most of you guys are more experienced than that, so I don't think you'd be making that mistake. But yeah, it's always good to kind of reiterate.
Cool. So we're going to talk about the deconstructing of the tech first.
Lovely. So yes, in terms of the modern versions, as sort of already stated, we're looking at 8 and above. So I'll touch on all of those versions. So we're up to 14 now. So I'll have a quick explanation through those. I think something that's really important to mention, and it's one of the reasons Java has stayed so relevant in the market, and also why it can be quite hard to keep up with. From Java 10 onwards, they moved to a 6-month release cycle. So that means from 10 onwards, 11 was released 6 months later, 12 6 months after that, and they're continuing with that cycle. So it's a really, really rapidly kind of evolving language. The modern framework is Spring. And again, that's a little bit like Java. It's kind of evolved over time. So you started off with Spring Core, and I'll talk through some of the kind of core elements to Spring. But that has then been added to with Boot and Roux and Data and all of these various different facets that add more complexity. We'll have a quick talk through the relationship Java has with cloud technologies, which ones are kind of most appropriate for them, particularly like within the DevOps world. Quick look into Java testing tools and a quick look into the big data technology that would make a modern Java skill set. And I mean, there is no defined, this is what a modern Java developer should be using, but it's combining the most up-to-date version of Java, the most up-to-date version of the Java frameworks with the most up-to-date approaches to testing, cloud tech, and big data technology, and kind of various different combinations of those facets. Cool. So I think first thing that is important to mention is there are 2 kind of different types of version release for Java: long-term supported versions and short-term supported versions. Essentially, long-term supported versions are much more comprehensive. They'll receive support, so they'll receive updates for up to 3 or 4 years. And they pretty much include all of the functionality of the versions that have gone before them. Whereas short-term support versions, so these are, you know, released every 6 months. They'll add some functionality to the kind of Java world. They might not include everything that was in previous versions though, because they need to kind of they need to package it within a certain kind of allocated amount of syntax. So you might find that you can do some things with Java 9 that you can't do with Java 10. But then there is a vice versa to that. Obviously, Java 10 does release some new functionality. So developers that do have an understanding of, say, Java 9, 10, 11, 12, they're going to have a lot of kind of strings to their bow in terms of what they can do with Java, because they've got all those different versions and all of those different functionalities that they offer. Cool. So the real big leap is Java 8 is from sort of Java 7 to Java 8. When really modern Java, I think, comes around, we don't see clients that are really looking at candidates that only know kind of Java 6 and 7 anymore. Again, that's something that's kind of evolved over the last, I'd say, 2 to 3 years. So Java 8 introduced Lambda expressions. So basically, they're really popular functional programming expressions that were previously used in Scala and Clojure. Basically allows you to write code a lot quicker and a lot cleaner. So less cluttered. You're having to write less to do the same function, and it allows you to basically just use commas and very simple syntax to break up bits of code and add functionality that wasn't originally there. So Lambda expressions massively sped up the coding time for Java. There's JavaScript Nashorn, which basically prior to Java 8's release, Java and JavaScript didn't really play very nicely together, but JavaScript Nashorn, which was included in Java 8, basically allows you to write JavaScript code directly into your Java code without worrying about kind of execution speed or the computability issues. So it allows Java to play nicer with the front end, essentially. They released date and time APIs. It was based on a previous system they had, but basically allows you to include date and time APIs into any of your coding. So if you want triggers and things like that based on time or based on date and all of that sort of stuff, it allows you to add that sort of functionality. It added stream APIs as well, which is kind of another function within that Lambda world. And then finally added concurrent accumulators, which basically means it allows you to run separate threads of code concurrently. Now, a lot of that is technical jargon, but to a Java developer, what it meant is that they could code a lot quicker, they could code a lot cleaner, and they could run code simultaneously, essentially. So it really kind of moved Java on into that modern world. And if you think back to the modern software engineering talk that we did, things like concurrency, things like resource allocation, all of these kind of modern concepts, Java 8 is what kind of allowed Java developers to start really getting to grips with a lot of these. So it was the big step forward. Cool. I'm not going to go through all of these, don't worry, because I think we're going to get really technical and really into a lot of jargon. I will share the link that kind of is quite a nice explanation of Java 11 in the Slack group afterwards. So if anyone wants to have a look, specifically what these things mean. But I wanted to have it on here because it shows that it is quite a comprehensive release. It's a long-term supported release. So they've packaged a lot of what's come before into this one big release. But yeah, as I said, I'll share the information afterwards. You can kind of do your own research into Java 11. Cool. And then we've got the STS versions. Similar to Java 11, I will share the resource so you guys can have a look through it afterwards. Again, it's very technical. It's getting very deep. But what you can see is there's not as many new functionalities released when you're looking at 9, 10, 12, 13, and 14. But it also goes back to what I was saying beforehand, the things you can do with with 12, you can't necessarily do with 13 as well. So there is value to kind of learning multiple versions. It's not a case that a Java 14 developer is the best Java developer if they didn't know any other other versions. I think the more modern versions and the more different versions of the syntax you're aware of, the more functionality you're going to be able to add to programs. Cool. So the big one, really, I think the one that is on most companies' lips at the moment, the one that they do seem to be very focused on within the Java world is Spring. So it's a really, really kind of comprehensive framework. So the framework's core features can be used by any Java application, but there are extensions for building kind of web applications on top of the Enterprise Edition in particular. So it doesn't impose any specific programming model, but it's become really popular within the Java community as an addition to Enterprise Java Beans, which is a kind of enterprise-focused IDE. And it's open source as well, so it can be added to by the wider community, which is what we'll kind of see as we go through it in a little bit more depth. Cool. So the top two are part of kind of the Spring core components. So this was released with the kind of first release of Spring. So you've got inversion of control. So it's a mechanism to achieve kind of loose coupling between objects and dependencies. What it means is it allows the Spring, it's inverting the control to Spring. So it's allowing the Spring framework to loosely kind of couple up the different objects, find out what's dependent on those objects, and make sure that the whole system is kind of tied together in the right way. AOP, so that's aspect-oriented programming, is another key component of the Spring framework. So it provides interceptors to kind of intercept an application. So when a method's executed, you can add extra functionality before or after the method is executed. So you're allowing the program to do what it already does, but it kind of interjects either beforehand or after and kind of adds in another element of functionality. Rather than having to change what the program does, you're just building on top of it and changing the end result to an extent. Then we're getting into the elements that have been kind of added to over time. So Spring Data is a high-level Spring source project, which purpose is to kind of unify and ease the access to different kinds of persistent stores, both relational databases and NoSQL data stores. So it basically gives, well, it massively increases the speed of you collecting data from various different databases that you may have linked up to your application. You've got Spring Remote Access, which is a framework that offers a range of tools within the kind of Spring remoting umbrella. And allows you to invoke remote services as if they were kind of available locally. So again, thinking back to modern software engineering presentation, that whole allocation of resources to make sure that you're not putting too much load. And again, we talked about kind of load bearing, we talked about allocation, not putting too much load on one element of the system or one area of the system. You're able to access remote resources, so essentially cloud-based resources. And then finally, Spring Integration is an open source framework for enterprise application integration. Again, it's a lightweight kind of framework built on top of that core Spring framework, and it's designed to enable the integration of solutions with event-driven architectures and message-centric architectures. So essentially, it makes it a little bit easier to build enterprise applications. Cool, the big one, I think, Spring Boot. I think this is the one that we see most common on job specs when we're speaking to companies about their need for Java developers. I think Spring Boot is pretty much the first kind of phrase on their lips. So it's an open source Java-based framework, again, built on top of that core Spring functionality, and it's used to create microservices. And that's the key to why it's so popular out there. It is kind of the go-to way of building microservices architectures with Java. Obviously, Java being pretty much the second most popular back-end coding language out there. You put those two together, there's going to be a hell of a lot of need for Java microservices architecture, which is why Spring Boot is absolutely crucial. And it can also be used to build kind of standalone and production-ready Spring applications as well. So you can use it to build new applications as well as build microservices architecture, which is going to house different applications or break up existing applications into different microservices that kind of depend on each other, which is why it really is the one, I think. Like, it is rare, to be honest, that we hear any other framework these days being classed as mandatory. Obviously, you'll get some nice to haves, but Spring Boot is very much the sought after tool on the market. Spring Brew is an open source software tool that uses convention over configuration principles to provide kind of rapid application development of Java-based enterprise software. We've got a picture on the next slide to explain what convention over configuration is. So I'll leave that to that. Then we've got Spring Batch, again, another open source framework within that Spring world, built on top of Spring Core, and essentially allows you to build batch applications, which again are often found in modern enterprise systems. So, I mean, you'll notice I've touched on the word enterprise several times during this. Again, that goes with Java being a nicely scalable language, a very available language in terms of the developers. So it is a good language choice for enterprises. Chances are you can hire quite a few Java devs, and it does give you a lot of different functionality there. So a lot of the things that have been added to Spring have helped with building enterprise applications. And then finally, Spring MVC is a Java framework which is used to build web applications. So touching on a slightly different type there. Follows the MVC kind of design pattern, and it implements all basic features of a core Spring framework, like inversion control, dependency injection, into a web-based application. Cool. So convention over configuration explained. So apologies. So it's using past data. It's using past experience to decide the next choice. So rather than having to configure something, it looks at, let's say, your past order history. Do you go in and order a flat white and a muffin at the same time every morning? Great, that's convention. Rather than actually having to make that order every single time, which I think is a nice little explanation there. Cool, and then we've got some honorable mentions. I mean, there are thousands out there. I could have picked a lot of different kind of frameworks there, but I think some of the relatively modern ones that we do see on some quite interesting looking specs would be Dropwizard, which is basically for developing RESTful web services. So it pulls together kind of stable, mature libraries from the Java ecosystem, and basically a very, very easy to use framework from the sounds of things, in order to build kind of high performance RESTful web services. So another web focused one, which would go obviously alongside some of the ones that we just touched on there. Vertex is a polyglot event driven application framework that runs on the JVM. It's actually very similar to environments written, basically it's similar in terms of its relation to Java, in the relation Node.js has to JavaScript, or Twisted has to Python. So it's almost, developing kind of new syntax and new ways of doing things, but based on that initial kind of Java code base. And then Play is a framework you will often see associated with Scala. I think, again, as we touched on the modern software engineering presentation, there's a huge relationship between Java and Scala. So you'll often find things you can use with Java, you can with Scala, and vice versa. And yeah, we do see Java and Play used as a combination here and there, but again, still very rare. Cool. So Java and DevOps. Obviously, we touched on what that Java modern framework would be. So we've already touched on kind of the version history and what that means, and obviously we're looking for 8 and above. We've touched on Spring being the modern framework and the various facets of that, particularly Spring Boot. I think the third thing that we mentioned that goes into a kind of very modern skill set is obviously the cloud and the DevOps related tech. So DevOps, big data, things like that, they are relatively universal. A lot of the tools you can use for Python, for C#, probably a little bit less actually, given that it's Microsoft, but they are coming out of their shell a little bit. But for most backend languages, the tools you can use are quite interchangeable between different languages. So Java DevOps is simply applying DevOps practices and philosophies to Java app development. It's not necessarily a separate discipline. Obviously, if you're a company that is very Java focused, then you probably will see some benefit from hiring DevOps engineers that already have a good knowledge of that Java ecosystem, just in terms of how quickly they can hit the ground running. But most of the tools are pretty universal across the backend languages. So if you're specifically talking about DevOps tools for Java, it would mostly be around the kind of build tools. So Ant or Maven are Java specific. But when we get beyond that, when we're looking at CI tools, when we're looking at containerization, the cloud platforms obviously themselves, they're pretty universal. So it's quite nice. Once you kind of have a good grasp with DevOps and big data, you can apply that to a lot of back-end languages. So it's always worth, you know, if you're out there recruiting for Python, you're recruiting for Java, you're recruiting for whatever it is, it's worth having that core understanding of kind of the DevOps tools, what they do and how they interact, because you can apply that to a lot of different roles. Cool. So we're not going to go into what all of these mean. I think we've covered that quite nicely in series 1, and obviously we've got a deep dive into an AWS focused DevOps engineer coming up later in the series, I think episode 4 maybe. So we'll go into all of these in a lot more depth in that instance, but what this does show is kind of the, I suppose, the most common setup that you would see within Java, or the most common setup that we see within Java anyway. So kind of Git being used for version control, as well as kind of test suites, automation scripts, things like that, probably hosted on GitHub or Bitbucket. Ant and Maven obviously build related tools that are focused on Java. Docker for kind of containerizing the applications. Then you would obviously have your automated testing phase. We'll come on to that in a second, where we look at JUnit, TestNG for kind of the automated unit testing, Selenium for the UI automation and things like that. Jenkins for your CI. I think Jenkins is probably the most commonly seen kind of DevOps tool on a Java CV, or personally anyway. I'm sure people would disagree. For your config man, anything from Ansible, SaltStack, Chef, or Puppet will do the job. And then, as always, kind of using AWS and GCP would typically be your cloud platforms of choice, just with Azure being Microsoft, with it being more focused within that kind of .NET world. And then obviously for your monitoring, again, Nagios, Prometheus, the Elk Stack, Splunk. There's lots of different options, and most of these are universal across various different languages. Cool. Java and testing. So when we're looking at, you know, a modern software engineer, they're expected to have probably worked within a cross-functional team, worked within an agile manner, and what that means is that they're expected to have some sort of test experience. I think the days of coders just coding are long gone. You do see the odd company where I always find it quite interesting that, you know, their devs don't test. But yeah, I think if you want to kind of class yourself as having an up-to-date modern skill set, then having that experience and knowledge of the testing world is absolutely crucial. So Java is a great choice of language if you want to ensure easy test automation processes, which is good news. It has a rich platform of tools and packages, and continuous integration with Java is easy with Maven, Gradle, and Jenkins. So kind of, you know, going back to the previous slide, you've got all of those DevOps tools that, you know, are the kind of market leaders that play nicely with Java. And you've also got an easy test automation process. So in terms of your own code being well tested, like factoring very well with the existing code base through that whole build and deploy system that we've discussed before, Java's a great choice, which again, you know, explains why a lot of enterprise businesses will use Java. It plays nicely with particularly a lot of the free kind of open source tools on the market, and free is obviously a word that a lot of finance directors really love when it comes to kind of onboarding new tools and things like that. So just a quick recap on the various types of tests, because I'm conscious it's probably 2 months or so since we last did it. So unit tests are used to test individual code components and ensure that the code works in the way that it's supposed to. So rather than trying to test 1,000 lines of code at once, you're breaking it up into, let's say, units of 10, and you're testing them at various points, so you can highlight where the bug is. And as we'll come on to in a second, it's heavily associated with TDD. Lovely. Integration tests. So check if the system as a whole works. So when you integrate all of your various parts together, does anything break? Does it still perform in the way we would expect it to, or perform in the way that the individual parts do? You know, is it a sum of all its parts essentially? And then functional tests. Check that each feature is implemented correctly by comparing the results against the kind of desired outcome. So it's a little bit more, you know, you're actually looking at the end product, not necessarily as technical as the other two, did it produce the result that we were looking for in the first place? And if no, then you can work backwards from that point to work out what's went wrong and at which point.
So talk to us about common tools, Phil.
Lovely. Yes, so all three of these are unit testing tools. JUnit, again, be by far the most common testing tool you would see on a Java CV. Been around for a while. Again, frequently updated as well. So it's really, really useful when it comes to when it comes to running your unit tests. In terms of TestNG, it's actually a kind of an upgrade on JUnit. It's the next generation. I think we're still seeing JUnit used a lot. And to be honest, I'd have to speak to some developers and find out exactly why that is. From the research I've run, it seems that TestNG is essentially an update on JUnit with it's more powerful, it's more user-friendly, it's got more features. But we're still seeing JUnit used super commonly. So I don't know if it's just that companies haven't necessarily onboarded TestNG yet, or if there is something that I couldn't quite find out that does still mean that JUnit kind of takes that crown. It's still by far the most common, but we do see a lot of TestNG around as well. And then Mockito is a mocking framework. So essentially what it allows you to do is create a mock interface that dummy the functionality, so you can actually see visually, does this work? And you can see the interface that you want the program to create in the end. Lovely. And then other ones to touch on are Selenium. So it's an open source tool which can be used for automating kind of UI-based tests. So it essentially replicates human action. Rather than a human going on and clicking on 100 things, it clicks on 100 things in less than a second and checks that they're all essentially working. JMeter is used for basically performance testing, load testing, and functional testing of web applications. And then Rest Assured is a Java-based library that's used specifically just to test RESTful web services. So we can see already that there are a lot of different tools that can be used. It covers a lot of the different types of application that you would be building in Java. So again, it allows you to really get some very good test coverage.
Cool. So how do we build great Java tests?
Of course. So use the frameworks, I think is one of the biggest bits of advice out there. Like Java, as I've already touched on, has a lot of great test frameworks. It's not like other languages where you're having to necessarily build tests from scratch. It's got a lot of tools that will assist you in this, that will automate a lot of different parts of it. So yeah, I think use the frameworks. I think use TDD. Again, this is something that, to be honest, I think it's over exaggerated how many companies actually use it on a day-to-day. I don't think we see that many companies that are actually using it. But it is very sought after when companies are looking to hire, because what it means is someone is proficient with good test coverage. If someone is following TDD, so they're writing their unit tests before they write their code, so it's allowing bugs to be flagged up as you write that code, rather than writing it all then going back. It shows a good attention to detail. It shows that they're happy to put the hard yards in at the start to get the right outcome, and it shows that they have a lot of value on kind of good code quality, and obviously it shows that they can unit test. So I think TDD is more of an identifier to companies that yes, this is someone who's proficient in testing, rather than something that a lot of companies are actually implementing themselves on a day-to-day. Darren, I don't know if that's something that you would maybe see in the market as well, or.
Oh. Sorry, I have myself on mute. Yeah, I would tend to agree with what you said just then. I think that's a fair representation in the market.
Yeah. Cool. Measure code coverage. So basically, the higher percentage of code coverage you have, and you can use tools like, I think Solaris is one. I think there's a couple of other tools that you can use to essentially estimate what percentage of code you have covered by tests. Obviously, if you've got 100% of your code covered by tests, then that would mean there were 0% chances of a bug being in there because you've tested every minute outcome. Let's face it, that's just not that's not going to be feasible. I think when when developers are initially coding something, very hard to think of every single edge case, every single thing that could potentially go wrong with the code. But the higher percentage you have of your test coverage, the better chance you have of deploying something that is bug free or as little bugs as possible. Externalize your test data whenever possible. So basically this just means you don't have to rewrite your test cases every time there's new data. It's essentially, saving a template in your emails or something like that in a very, very basic sense. Use assertions instead of print statements, so it leads to less cluttered code. I believe in the past, when a dev was testing their code, they had to essentially add a print statement at the end of every line of code. You can imagine within 100 lines of code, that's a lot of different phrases that you're adding in there. It's going to massively increase the amount that you're writing at the end and make it harder for someone else to read. You can use build tests that have deterministic results. And I think this is, it's again another quite obvious one. If I ask you, let's go simple, 2 add 2, unless I know it's 4, how can I say whether you're right or wrong? So if you don't know what result you're expecting, the tests are completely meaningless. You can't, a program can't make a subjective judgment of whether this is right or wrong. You have to be able to tell it, this is the outcome we want. And with that in mind, this is what we want, so everything else are the outcomes that we don't want. You have to be able to give it a deterministic result. You have to be able to lead it to where you want it to go. And then test negative scenarios and borderline cases in addition to positive scenarios. So this is what I meant about trying to think of as many edge cases, trying to think of as many ways that the user could, interact completely wrongly with the application. You're thinking about someone using the application in a very logical way, implement, type numbers into this element, you add text to this part of the website, you click here. Users don't always act in such a rational manner. So it's trying as much as possible to think about as many different edge cases as you can. But going back to that test coverage percentage, the higher you get it, the better. Realistically, you'll never get it to 100% though.
So talk to us about Java and data.
Cool, yeah. So again, like as with Java having such a big suite of testing tools, which are very good, with it having such a quick version update, with it having Spring, which is such a comprehensive framework, to go along with that, most open source big data tools are Java based. So they're going to play quite nicely with Java as well. So we're thinking back to again, that modern skill set. You've got updated versions, frameworks, you've got lots of cloud tools that play well together, lots of testing tools that play well together with it, and lots of data tools that play well together with it. So when you're looking at the modern world of software engineering, with cloud computing, with microservices, with real-time streaming of data, and all of this sort of stuff that's getting more and more popular by the day, you can see why Java is still the choice for a lot of companies. So one of the key kind of reasons behind this is Java's very, very deeply ingrained within the open source communities. There are a lot of Java devs out there, basically. And obviously, the more developers you have out there within an open source community, the more you have that are prepared to use their spare time to build new frameworks, add new functionality, all of this sort of stuff. So you get a more rapidly kind of evolving language. So a lot of Java code is publicly available. And companies like Apache in particular, but Google as well, have been kind of borrowing bits of this, but also adding to it by creating new tools. The most prominent one, to be honest, at the moment is Hadoop. That is being replaced very slowly by kind of the kind of Spark and Kafka world. But the kind of Hadoop ecosystem is all built on Java, and all of those different kind of elements within it work very well with Java. So again, why I'm not going to go through all of these in full detail, but the reasons you would kind of choose Java, aside from the fact that it's open source and very available, but it's quite simple, so it allows you to kind of create applications in a more simple, user-friendly way. It's portable, so it can be run anytime, anywhere. So again, whether you've got a distributed team or whatever hardware that you're working on, you can utilize it. It has good allocation, again, so something that we've touched on quite a lot of times, load bearing and resource allocation within the system. So it has good garbage collection, so it's cleaning up any wasted memory, and distributing your memory in a very simple way, which allows the program to run nice and quickly. It's distributive, so it's highly networking competent. So again, if you've got distributed teams, you know, you're doing cloud-based development, everyone's working in different parts of the world and adding to the same project, then Java plays very nicely with that, and it's extremely secure, you know. So I think within those 5 reasons, again, it gives you another insight as to why Java is still very popular within all sorts of different contexts. Cool. So quick rundown of these. Again, not going to go into massive detail because we are going to look at breaking down a data engineer spec later on in the week. But I've already touched on Hadoop. It's a free Java-based programming framework which processes large data sets in a distributed computing environment. Probably the most popular at the moment, but it is being replaced by the kind of Kafka and Spark real-time streaming world. Hadoop does support RTS, I think, real-time data streaming, but it also supports ETL, so extract, transform, load, which is kind of the slightly older version. Kafka, so here we go, it's a distributed streaming platform that is used to publish and subscribe to streams of records. Spark works similar to Hadoop and the MapReduce framework, and it's getting more popular, as I've already kind of touched on, for that big data real-time processing. And Spark is a cluster computing framework that can run on thousands of machines. So distributed systems, big data, again, within that that Spark world. And then Mahoo is an open source big data tool and a popular kind of Java machine learning library. So if you've got Java-focused big data engineers or Java-focused machine learning engineers, then Mahoo might be something that you're kind of looking out for. Cool. JFreeChart is a data visualization tool for Java. So again, while Java isn't a very popular language within data science, you do see it. And it's not just data scientists that will use visualizations, it's primarily them. But obviously a developer or even a data engineer that's using Java may be involved in building some pretty simple visualizations with FreeChart. Deep Learning 4, which I believe has I think there's a version for JS as well. I think it's D4JS. Is a Java library which is used to build different types of neural networks. So again, you know, even though I guess Python and Scala really kind of take the title when it comes to big data, we can see that Java can be used in a lot of different ways, particularly in conjunction with Apache Spark, to do a lot of things that a data engineer would want to do. And then Storm, so this is ideal for Java streaming applications, and it's among the popular big data tools for developers. So again, that whole real-time streaming element.
And is there a compromise?
Yeah, absolutely. There definitely is. I think it comes down to 2 things, like how long do you have to upskill? So while Java 8 was a huge jump in terms of the functionality, in terms of the syntax, it's not massively different. I think, you know, you could absolutely take a Java 7 developer. They are getting a little bit rarer, but I think that if anything, that means they probably need a helping hand more than anyone. And you could get a talented kind of Java 7 developer, and they could learn Java 8 or 9, 10, and the future versions in a very short space of time. Apologies. With Spring, I think, again, there's 2 ways to look at it. So you could look at a Java developer that, say, had only used Hibernate or had only used some older frameworks. Again, in terms of learning a framework, I think if you speak to developers, like a lot of them learn, you know, 3-4 frameworks a year. So you're probably talking 2-3 months really to pick that up. So how long do you have to upskill that person, and are there tasks that they can be working on while they're upskilling in other areas? So I don't know, is there some debugging of kind of some legacy code that they could be working on while upskilling in other areas, or do they actually have some really good cloud experience so they could add to a different team, or have they got some data knowledge where again they're going to be able to add to a different team? So if you look at to tick every box, I think you are in a little bit of trouble at times, even though there are a lot out there on the market. So I think really thinking about how long do we have to upskill and which areas can we upskill in, and then secondly, what's the end result you're looking for? So if you're looking for someone who is competent with Spring Boot, let's say, because you want someone to come in and build you microservices, well, if you have a C# developer who knows some Java, never worked with Spring, but has worked with .NET Core for the last 4 years building microservices, they understand the microservices architecture and they understand Java. They just don't necessarily know how to build microservices with Spring Boot. So that learning curve actually might be even shorter than someone who is primarily a Java developer but has never built microservices. So I think it's important just to really kind of dig into what do we need in the short term, how long do we have to upskill these people, what can we compromise on, and what is absolutely mandatory, and have that conversation before you go out to market. Because I think often that happens weeks or sometimes even months down the line, and you could have made a hire within that time.
And talk to us about some technical qualifying questions.
Yeah, absolutely. And so I am specifying technical here. Obviously, there's a lot more things I would want to ask and get information from any candidates I was speaking to in your guys' shoes. And obviously, there is more to it than this. Looking at portfolios, looking at code, looking at contributions, and all of this sort of stuff is huge when it comes to deciding whether someone is right for your company or not. But in terms of actually qualifying their level with Java, what version of Java are they working with? How long have they been working with it? How comfortable are they with it? What other versions do they know? And have a chat with them around that. And it is useful to know release dates. I very recently had a chat with a developer who told me very proudly that they were using Java 13 at their last company. I then had a quick Google and realized that Java 13 wasn't released until 3 months after they'd left that particular company. So it is worth knowing these dates because they can act as indicators. And don't get me wrong, this person was absolutely lovely. They had some personal knowledge and we're trying to over-egg it, like didn't hold it against them at all. But it can give you the indicator whether someone's kind of leading you down the garden path or if they have been working with it. What frameworks they're working with. And then, if they say Spring Framework, specifically, which elements of the Spring Framework and what have you been doing with it? Have you just been using a bit of the core functionality or are you using Spring Boot every day to add to microservices? Testing, so do you test your own code? If so, what forms of testing are you familiar with? And do you follow best practices or are you familiar with best practices like TDD? Agile, I think, Agile itself is pretty basic these days. I don't think there's many companies that are still using waterfall or anything like that. But if your company is very kind of Agile focused and really, really focused on, say, XP, like extreme programming principles, then this is absolutely something you want to qualify on that very first call, because if they don't understand those ways of working and they're very important to you, then they're probably already, not the right person for you unless you've got the time to upskill them in that area. And then databases, what databases have you worked with? If they've been working with a lot of kind of NoSQL complex databases, again, that could be an indicator that they do have some knowledge or some advanced knowledge of kind of big data and things like that, which may be useful. Great. From an architectural perspective, I think it comes back to what I was saying on Spring. Microservices really is the architecture that companies are looking for at the moment. So again, if someone's got microservices in their tech stack on their CV, or they mention, oh yeah, I work with microservices, specifically, have you built microservices? Are you maintaining microservices? Or are you just working in a business that has a microservice architecture? Because you can kind of say I work with microservices for all three of those, but they're very different indicators as to how relevant this person is to your company. Cloud and DevOps, so have they worked with cloud platforms and DevOps tools, AWS, GCP, Azure, Docker, and again, how have they used it? Not just have you used it, have you heard of it, are you familiar with it, how are you using it, how often are you using it, what are you doing with it on a day-to-day? And the exact same applies to big data as well. Don't take skills as a surface level. Great, this person knows Kafka. Great, this person knows this. No, how are you using Kafka? How are you using Spark? What are you doing with it on a day-to-day basis?
Great. So now we're obviously moving on to deconstructing experience and salary, and we've got just over 10 minutes left, Phil, just to keep you on time.
Cool. So took some guidance here from pay scale for anyone who is familiar with the UK market. To be honest, as much as it's verified from a kind of respectable company, I know some of the samples aren't that big. I actually disagree with it. I think they're tying salary to seniority, which is absolutely not what we see in the market. I think Darren would agree on this as well. I think we've seen developers with 2 years experience get 50k, and we've seen developers with 10 years experience get 50k. It's not down to your experience, it's down to what you're doing.
Yeah, me and you had this analogy beforehand that it's exactly what you said, where it's what are you doing with this? Because you'll get some candidates that have gone above and beyond that might have 2 years experience that actually are probably better Java engineers than someone with 15 years experience, because that person with 15 years experience just stayed very shallow and just focused on very old tech rather than innovating. So I think that's more what you want to look at when looking at engineers.
Yeah, absolutely. And I think that sort of stuff's harder to quantify, so I can kind of see why pay scale's gone down this route. But I think it does give you an indicator anyway of the sorts of salaries that are being paid, but I wouldn't necessarily tie it to those years of experience, to be honest. But I think, yeah, particularly for the 1 to 4 years, I think that's pretty accurate. I think when we're looking at, having to work 20 years or higher to get 100k, definitely not what we've seen in the market. Cool. I mean, yeah, okay, is close enough to 44. Bonus is kind of 3.5, and that is pretty much something that a lot of developers are expecting these days. They are looking at kind of bonus and extra package, as I'm sure you guys are all very aware. Although one thing I would say, and we are actually going to be doing some podcasts around this in the near future, is that often what you'll find is that learning is more important to developers than money. Like, they're already on very good money. They know they can get a promotion and step up. I think advertising what they can learn at your business, whether that's on the job learning or whether that's, access to courses, I think is often a better sell, because that allows them to upskill and become better developers for the future, to then go out and get, a bigger salary next time. But we can see here the split between male and females. It pretty much goes with the industry average. I think it's 90-10. And then we can see here the sorts of things that are impacting your salary. So actually surprised that Spring's only 1% up. RESTful web services, I think, are very common. So, I can see why they would be. But what it does do is it shows that older tech, right? So J2EE, Hibernate, if they're your main skill sets, that's actually dropping the salary that you could basically expect on the market. A little bit C JavaScript on there. I mean, it's one data set, so I'm not going to put anything from it. I guess that would tell you that full stack development is not as popular as it was. But yeah, I'm not entirely on that, to be honest.
Talk to us about availability, Phil.
Lovely. So yeah, this is just a quick search run on LinkedIn. So again, not the most scientific. This is UK wide. Essentially, people with Java developer as a title. Did the same with C#, JS, PHP, and Python. So we can see here, it's of the kind of most popular languages out there, it's probably the third most popular. But I would say when in the market, I think it is more popular, to be honest, in terms of demand than C# most of the time. I think recently we've seen a big increase in demand for C#. For a long time though, Java was very much the one that we were seeing as the most in demand. And as ever, JS is a bit misleading, because most of those will be front-end developers rather than kind of back-end nodes.
And red flags when looking at experience versus salary.
Yeah, great. So just to kind of reiterate on these again, so we've got the older frameworks there, which are probably going to drag the salary down a little bit. We've got Android development, which is a red flag to be aware of just in general. Please do go back and listen to the mobile presentation if you want more insight into that. We've got the responsibilities. So again, when I was going through those qualification questions, how are you using microservices, or what are you doing with microservices? Because microservices isn't a task you do. Microservices is an end result. So if someone has microservices as a tech stack skill, yeah, great. What are you doing to build microservices, and how are you interacting with them? And I think, yeah, in terms of kind of the fixes, monitoring and tickets, again, very important to understand how is someone using Java? Are they building on Greenfield? Are they writing new code? Or are they fixing things and monitoring things and basically doing legacy rewrites and all of that sort of stuff? Lack of testing responsibilities, I think, is pretty much pretty final in the market these days. I don't think there's any companies really we see that are accepting people that have no testing knowledge. Some have higher bars for it and lower bars for it. But yeah, I think really you want to see candidates that understand how to unit test and understand what good test coverage looks like. No cloud experience, again. I mean, as we've how many times today have I touched on enterprise development, distributed allocation, all of these different things? If you don't have the cloud available to you, then a lot of these different concepts that are unlocked within the modern development world just aren't available to you. And then no experience building microservices. As I said, that seems to be one of the main responsibilities clients are looking for at the moment. They're looking for people to come in with experience of building out microservices. I noticed someone's raised their hand.
Oh, I can't see.
Oh, so I think the guys that are raising their hand, do you want to maybe pop a question into the chat if you have one, and I'll try and get that answered before the end.
So let's look at deconstructing the interview process super quickly.
Yeah. So look, this is where it gets very subjective. Like all the tech stuff, I think there's the right and wrong answer. I think this is what we see as a successful interview process, both in terms of companies that have had long-term success on the platform and have not just long-term success in terms of making a lot of hires via HackJob, but having hires that kind of stick as well. So intro calls to qualify, sell, and establish a relationship, get them engaged. I know I'm going to be preaching to the choir with a lot of this. I think, often the intro call is seen as a one-way street. It's a box ticking exercise, and I absolutely hate that. We've had a few clients where that is the case. Jump on 10 minutes, ask 10 questions, great, done. No, like that intro call is an opportunity to sell in the company, to really get to know someone, to make sure that they come off that call prepared to, put the time aside to go into your next call or do your test or whatever it is. The tech calls are relevant questions tailored around the role, so you both establish they're a good fit, but also engage them at the same time, right? You also want to get them excited about the tech that they're using. You want them to come off the call believing that they are the right person for the role, as much as possible. Because again, they're going to then hang around for face to face. They're then going to, you're going to be the company that they essentially want to join. And then face to face, essentially the final confirmation that you have the right person technically and culturally, as well as your opportunity to really sell in the business and make sure that if you do want to offer, they want to accept. I think would be and look, it's fairly basic 3-stage. I know some people will say, well, we have to do a tech test, we have to do this. Great, build it into your face-to-face. There's nothing better than getting someone on site, not at the moment, obviously remote, and doing a proper pair programming with them during that session, especially if you're pairing them up with someone who's quite engaging, prepared to ask their questions. It's a two-way exercise. You can gauge their coding ability while also, giving them access to someone technical where, you can tell them about a few of the cool things they're working on at the moment and give them more of that insight from a technical perspective, which I think is very important.
Phil, so I guess building on that, because I'm mindful we've only got 2 minutes left of the thing. So I guess a question to throw at you right at the end. So question from Drew that raised his hand. So with regards to candidates who have 10 years experience in a company, then get trained up in a new tech stack, do you think they would see an increase compared to a candidate with 1 to 4 years experience in the market?
So someone with 10 years experience working with the same tech, and then they upskill so that they're using the same tech as someone with 4 years experience. Is that?
So what I'm gauging from this question is, if someone went from PHP to Node and they've got 10 years experience and learnt the new Node stack, Do
Yep.
you think that someone that had 1 to 2 years experience in Node already, but that's all the experience they've got, do you think that they would earn the same salary, or do you think there would be differentiated salaries between the two?
Yeah, great. So again, there's no hard and fast rule, but absolutely be situations where both of those are right. I'd say in general, though, someone with 10 years experience would probably be earning more in that situation. And part of that's just down to expectations, right? If you've been working as a developer for 10 years, chances are you're already on a salary that's mid 50s, let's say pushing 60, something like that. You've got a lifestyle that accommodates that. So you're going to be going forward at that level. I think if you're 1 to 2 years out, there's less of a chance that you've had the time to make those steps up yet. Obviously, if you're a superstar, Oxford grad, something like that, then yeah, a lot of them do go straight on to 50K. Most developers, I think we find in London, are working their way up from around 30 to 35. So it is a slightly more gradual process. And I think someone with 10 years experience, like, they're going to bring other things to the business. They probably bring some mentoring experience. They probably bring some leadership, potentially more confident getting involved in technical conversations, although that's a massive generalization, absolutely won't be true in all instances. Should have, and going back to like the DevOps tools, how I was saying they're pretty much universal, the big data tools, the cloud tech, all of that sort of stuff. If they've got good experience with all of those, then they're coming in with a hell of a lot more experience with relevant tech, even if it isn't with Node. So yeah, I would say in general, yes, but absolutely there will be cases that break that rule, definitely. Lovely. And I think on the rest of the interview stuff, so what we'll do is obviously share the presentation, share the deck. So there's a bit more advice on specifically like the interview stages and what you should maybe be asking and things like that. But I'll leave that for you guys to read through in your own time if you feel it's relevant.
So thank you everyone so much for joining us today. We will send out the deck and we'll also send a recap video of all of this session via YouTube. So we'll send them out via email later this afternoon. Thank you so much, Darren and Phil, for kind of doing this session today. Really appreciate it. And yeah, we'll see you guys next week.
Cheers, guys. Thank you.
Cheers. Bye.